Okay, so this is our first lesson on waves, and we're starting with light. You should already have downloaded, printed, or attached to your electronic workbook the personal learning checklist, the keywords list. You should have the Quizlet to hand so you can check your understanding, your recall rather, of those words. Now, the first thing that you should do, just to get yourself into the swing of things here, is to write down 10 things you know about light. Write them down, think about them, pause the video, do that, and then start the video again, and we'll compare lists. So, the sorts of things you might have said: light can be reflected, it travels in straight lines, you have white light, you have 7 different colours of light, the colours of the rainbow, light can form shadows, you have light changing direction when it goes from air into glass, maybe air into water, water into air. This is why swimming pools don't look as deep as they actually are, for example. You might have said that some objects give out light. You might even have used the word luminous to describe that. Some objects you see because they reflect light, non-luminous. So there's 10 things. You might have said some others, but there's 10 things that you might have said. So here we have a series of images for you, and the question is, do you see them because they are sources of light, that is to say they are luminous, or do you see them because they reflect light, that is to say non-luminous? So over here, well, I suppose here we've got 2 things, haven't we? We've got the cloud and we've got the lightning. Here we've got the moon, here we have a window, and the window has glass in it which allows light through it, so that would be a transparent object, whereas you have the window frame which does not let light travel through it, so that's an opaque object. Over here we have a picture of the sun, and that gives out light, of course, that's a luminous object. Here we have a firebug, and it can give out light. A fire, and the wood before the wood burns. The chair, a candle, the wax and the flame. A glass, a lamp with a bulb in it, a lampshade and a body, the pen, cutlery, a hoover, a desk with a mirror. The mirror reflects light. We did the chair, we had the tree, of course, with the Christmas lights on it, very seasonal. So, which of these are sources of light? Just pause for a minute, maybe stop the video and think about that. So we have the fire gives out light, the lightning gives out light, the moon doesn't give out light, the moon only reflects the light from the sun. So that's a non-luminous object. You have the opaque window frame and the transparent glass. You have the sun, of course, which is a source of light and thermal energy. So it is a luminous object. The abdomen of the firebug is a luminous thing intermittently. The pen, the cutlery, the hoover, the desk, the mirror, the chair, the tree, the body of the candle, the glass, these are all things which are non-luminous, whereas the sun, the abdomen of the firebug, the fire, the lightning, the bulb in the lamp, the flame on the candle, these are all luminous objects, as are the lights on the tree. So we have non-luminous objects, we have luminous objects, we have transparent object, we have opaque object. The glass, well, it's hard to tell here. If this was clear glass, it would be transparent. If it was frosted glass, it would be translucent. That is to say, light travels through it, but you can't really see clearly through it. You couldn't look through it and see someone's face. That would be a translucent object. So greaseproof paper, tracing paper, these are translucent things rather than transparent like glass. And we can see in passing that we have a red chair, we have a green tree, so we can see different colours. And we will come on to explain why that is a little later. So, we have luminous objects, we have luminous objects, and we have non-luminous objects. Hopefully you're happy with that. And we did go on a little bit and talk about transparent, opaque, translucent as well. So, we're today looking at how light travels and how we can represent that using a ray diagram. We're going to explain how we see non-luminous objects. Luminous objects, obviously they give out light, that's how we see them, but how we see non-luminous objects and why we can't see around corners. So here's an experiment. I don't know whether you have the ability to do this at home, but if you can shine light down through a piece of hose pipe maybe, or maybe a slinky with all the coils very close together, then you can see that light will only travel through this tube if the tube is actually straight. If you bend it, it doesn't work. You can see here light traveling from the sun behind the clouds through gaps in the clouds, and you can see the beams or rays of light coming through here. And the reason that you can see the beams at all is because they are reflecting off dust in the atmosphere. Again, spotlight beams, and you can see the light reflecting off the dust in the atmosphere and the air here. And again, same idea here. Lasers, of course, are very fine beams of light, or can be very fine beams of light. So, two main properties of light we're going to look at here. The light comes from the light bulb, in this case, to the eye. There's a common misconception that it goes the other way, but the light comes from the light bulb to your eye. And it travels in a straight line. We know that because we can't see around corners. So there's the first thing about light. It travels in a straight line, always in a straight line, which means we can mark the path of the light from the eye as a straight line, and we want to put an arrow on it to say this is the direction of the travel of the light. So, our first learning objective, how light travels, how we can represent it using a ray diagram. Now, literally the ray diagram is a straight line with an arrow on showing where the light started and where it ends up. That is your ray of light. And we're going to develop ray diagrams a little bit. So, what if you want to see a non-luminous object? So, the light bulb is a luminous object. It's giving out light. It goes from the light bulb to the eye in a straight line with that arrow pointing from the light bulb to the eye. But what if you have this non-luminous object, this white rectangle here? Well, the light will travel from the light bulb to the object that doesn't give out light by itself, but it reflects that light into your eye. So now you see how you have a ray diagram. You have a ray coming into the object, you have a ray coming out from the object into your eye. That's how you see it. And here, where the ray changes direction, that's reflection at the surface, right? So, keyword reflected or reflection here. And this is what happens with non-luminous objects. Pretty much most of the things we look at. So, how would you draw the ray diagram from the sun how the light gets to your eye so you see the ball, and how would you draw the ray diagram for seeing the tree. Again, think about that, pause the video, and then come back and see. So the ray will come from the sun to the ball, and from the ball to the eye. So there'll be a straight line from here to here with an arrow on it, and a straight line from here to here with an arrow on it going from the ball to the eye. Here we have the straight line from the sun to the tree, and a straight line from the tree to the eye. So a straight line with an arrow on it going from left to right, and a straight line with an arrow on it going from right to left into the eye. So here's a question. You have a copy of this question in the Word document that I've given you, the Google Doc. So you can actually do this. So you should pause the video and do the question. So we have Alika over here and Sarah over here. Alika wants to use the sunlight to signal to Sarah. What might she use to do that? Well, I think you might probably have said a mirror, but any shiny object will do. So the sun hits the mirror, reflects off into Sarah's eye. So we have mirror, we have reflect, draw the ray diagram. Well, that's a ray from the sun to the mirror and from the mirror to Sarah's eyes. It's important it goes to her eyes and, not her arm or something, because it's her eyes she's using to see. Okay? So that would be a straight line from the sun to the mirror with an arrow on it, and a straight line from the mirror to her eyes with an arrow showing the direction from the mirror to her eyes. Now, there's two kinds of reflection. You have nice, smooth, flat surfaces, which are what mirrors are, and you can see your face in a mirror, so you have a nice, regular reflection. And we'll do more of this at GCSE, but a flat surface like this will give you a nice, regular reflection, whereas a rough surface, it's still being reflected, but it's being scattered. So you don't get that nice regular reflection. You can still see it, light is still bouncing off it, but you can't see your face in it. And that's because as far as the light's concerned, it's rough. It might not be rough as far as you're concerned. The surface of your desk is probably not shiny enough for you to see your face in it, but it still feels flat. So as far as the light's concerned, this is a rough surface, and it scatters the light from it, so you don't get a nice regular reflection. You can't see your face in it, but you can still see that the object is there, still reflecting the light. So we see non-luminous objects because they reflect light, and some of them will reflect it nice and regularly like this, like a mirror, and some will reflect it, scattering it in different directions, but it's still reflected. And we see non-luminous objects because they reflect light. So you have these two main properties. Light travels in straight lines, and that's always the case. And light travels at very high speeds, 300,000 kilometers per second. That's about 7 times around the world in a second. It's very fast. Whereas sound travels at about 300 meters per second. So this is about 1,000,000 times faster than sound. So what happens if something gets in the way of the ray of light? Well, here we have a cat, and the light's coming in from over here, obviously, and you can see that where the light can get to, you can see the light, but where the cat is blocking the path of the light because the cat is opaque, does not let light travel through it, you have a shadow. So regions where the light cannot get to because an object is blocking it, that's where you get your shadow. And here's a diagram of how the shadow forms. This is the ray which comes closest to the top edge. So no ray can get closer than that. And this is the ray which comes closest to the bottom edge. No ray can get closer to that. So there's an area here where no light can reach. And so you have a shadow. Of course, this is an opaque object. If this was a piece of glass, this shadow wouldn't, a piece of clear glass, this shadow wouldn't happen. So going back to transparent, translucent, and opaque objects. Transparent, light can travel through it, your clear glass in your windows. Opaque, light can't travel through the window frame or the walls. You have your curtains might be translucent because you can see sunlight coming through them. There might be blackout curtains, you may not be able to see through them at all. But light passes through some curtains, maybe your blinds, for example. If you have blinds on the window, the blinds don't stop all the light coming through, maybe, but they do stop a lot of it. So you can see light coming through them, but you can't see clearly through them. So they are translucent. So light travels in straight lines at very high speed, and if something opaque gets in the way, you get a shadow. Here's the question I know I've given you. The previous question I said I'd given you, I hadn't, so you needed to do that one from the screen. But this question you do have a copy of on the Google Doc, and you should do that. It'll take you 4 or 5 minutes maybe. Now you have a Word document version of this, so you can draw directly on the document, and I want you to upload that so I can see it done, please. So do that. That'll be what I use along with your notes to assess your progress in the lesson. This one I couldn't give you a Word document of, I wasn't able to convert it, but here's another question that you can do. You can see here the shadow of the full milk bottle. You have to look carefully here. This one's empty, and this one clearly isn't empty because it looks different. So here we have a full milk bottle, and you can see the solid shadow behind it. Here we have an empty milk bottle, and you can see the outline of the milk bottle, but the light is traveling through the milk bottle, so you don't get a shadow in here. You have a clear glass. You have a obviously not clear plant pot and plant. You have an opaque mug, this being opaque as well, I should have used the correct word, an opaque teapot, opaque cola bottle, and translucent, perhaps transparent cola bottle here. So we've looked at how the shadow is different. It says draw the shadows on the diagram for the glass, the mug, the teapot, and the cola bottles. What's the difference between the shadows of the empty and full cola bottles? What do you think would happen if the lamp is raised? What will happen to the shadow? If a lamp is lowered, that is to say, if a lamp was to be put higher up here or brought lower down here, what would happen to the shadow? Think about that. Think about shadows during the day as the sun changes position in the sky. See if you can think about how that would look. And then we want on the diagram a ray of light going from the lamp to the full milk bottle, and make sure the light ray has an arrow on it. So do that. Shouldn't take you more than 5 minutes to do it, and then start the video again. So we've already answered question 1 in my discussion of the question before you did your bit. Draw the shadows of the diagram for the drinking glass. Well, you'd expect to see the outline of the glass back here, very much like you see the milk bottle outline, but light will travel through the drinking glass, so it will look very much like this, but just a change of shape as the light travels through. How is the shadow different between the glass and the mug? Well, the mug is opaque, the glass is transparent, and so the mug will give you a solid shadow like this, whereas the drinking glass gives you just the outline. If the lamp was raised, then these shadows are going to get shorter. More light can get beyond the milk bottle. If the lamp is lowered, the shadows will get longer because the light is firing from a lower angle, and so the shadow will get bigger. And on the diagram, a ray of light from the lamp to the full milk bottle, it's going from here to here. You could also show it reflecting off, but I didn't ask you to do that. So, there's our presentation for the day. You've had the question I want to do for assessment. You have some keywords that you need to define in your notes. You've got the keyword list, which does more than just today's lesson, but you have a keyword list. You have the Quizlet. You should spend some time learning those words using the Quizlet. That, together with answering the question, is the rest of your lesson.